everyone. My name is Nincic, and I'm the CTO at PDF Tron Systems, where over years I had the opportunity to work on a number of interesting projects related to the subject, namely semantic content recognition in PDF. This is one of my favorite areas, and it's one of our missions as a company to make computers understand documents so they can read to us, they can properly reflow content on mobile devices, and so forth. So, what to expect from a session? So this is not like an information session. I'm not going to go into details of what is tagged PDF, what is PDF UA, or analysis of semantic content structure algorithms. I'm not going to talk about technical details. There's also already lots of information available on the web, and lots of information was already covered as part of other sessions. I'm also not going to talk about a future of AI, like Skynet, and how the computers will take over the world. Instead, I'm going to comment on the current state of the field of document understanding, and also invite everyone to a community project to hopefully kickstart innovation in the field. So to start with, what is the document structure? And what is semantic structure recognition? Document structure refers to a hierarchy of semantic labels that give a meaning or an interpretation to a document. So in PDF documents, we have a display list. So each PDF consists of a display list, which represents a physical representation of the document on the page. The nodes of the display list are the leaf nodes of the structure tree. So the structure tree effectively labels and connects bits of content on the page into a meaningful whole. So for example, a bit of text on a page might be identified and labeled as a table cell, and that table cell might belong to a larger table, which might span multiple pages, which might in turn be part of a section or a book chapter, and so forth. So in some ways, logical structure is similar to grammar in human languages, with some important differences. A couple of things to note about the structure is that there is no single or universal structure representation out there. Large part of our educations goes into learning how to read documents with progressively more complex structures. So for example, children's books have little or no structure at all. And then as we grow, we learn more complex documents. We learn how to read newspapers, magazines, which have more complicated structures, but they don't have well-defined or rigid rules like scientific papers. And some documents like forms and ballots are specifically designed for automated processing by machines. Some documents, like computer listings, can be interpreted only by a small subset of population, like developers or machines. So there is a large array of different potential grammars out there, and the boundaries between them can get blurry. Another thing to note about the structure is that a single document can have multiple valid semantic interpretations. So for example, a document that prints identically may have very different semantic representations in applications that generated the document. So Microsoft Word may represent a bit of content as a list, and Illustrator may use a table representation. Conversely, a single semantic representation may map into infinite number of physical representations. So basically, there are many ways to render the same visual output. Like Hello World can be outputted with text output operator, or it could be, we can use FormX objects, or we can use path elements, and so forth. One thing is that about logical structure is the terms logical structure and semantic structure recognitions are frequently used interchangeably, but at least for the purposes of the current presentation, I will make a difference between them. So the logical structure usually deals with a particular grammar, and it can be embedded in PDF document, but this is a subset of the more general structure recognition problem which deals with the space of all potential grammars, where the recognition rules can get significantly more complex and fuzzy. So the structure recognition is more general problem, and it relates to how we humans understand and interpret documents. So good question then is, if PDF already allows us to embed explicit logical structure, why do we need to bother with automated structure recognition? So we have already things like tagged PDF, PDF UA, etc. And the answer is that, unfortunately, it does not solve the general problem for a variety of reasons. First of all, most of the documents out there do not contain any meaningful logical structure. They're not valid PDF UA files. Also, manually labeling all these documents would be prohibitively expensive, even if we use some semi-automated techniques. And going forward, app developers have a little incentive to justify extra cost in producing valid PDF UA files. So besides the cost to the actual specification, PDF UA, which is not free, there is the cost in interpreting the spec, mapping internal data structures into format required by the spec, and so forth. It's also important to note that tagged PDF, it just includes a very basic set of tags. And these do not serve all requirements of all applications out there. Most importantly, the requirement for embedded structure runs counter to the appeal of PDF format as the output format. So PDF became popular because it's an effectively assembly language of document formats. And many documents are still produced as a result of printing a document, perhaps through a virtual printer driver. So it is, in some cases, impossible or fairly difficult to embed explicit logical tags. And it's not straightforward to produce valid PDF UA, even if developers are completely sold on the spec. So for these reasons, it is unlikely that embedded document structure will remove the need for automated structure recognition in most areas other than niche or heavily regulated environments like government. So to give some motivation to further discussion, it's good to understand some applications of document recognition. So a couple of them I already mentioned before. Important area is reflow, which is now becoming very important with proliferation of mobile devices. Another important area is accessibility. Other areas include content repurposing, like which is conversion of PDF to alternate representations like Word, EPUB, and so forth. Search engines, data analysis or document summarization, and so forth. Actually, this importance of document understanding is already well recognized by both academia and the industry. And there are multiple conferences dedicated solely to this subject, and countless papers were published over the course of the last 30 years. On the industry side, there are significant investments by many companies into furthering the state of the art in this field. So the question then is, where are we now? And the answer is that structure recognition works. Sometimes. But this is exactly the same thing that we could say about the state of this document understanding, let's say 15 years ago. It works sometimes. Unfortunately, sometimes works and PDF are generally not a good match. And we adopted PDF format because we expect it to work always. The interesting part is that all the R&D effort translate into relatively small incremental results. And I would argue to say that we did not, this effort did not solve problems for most of users. So today, people with disabilities still can't count on PDF. Content repurposing is still error-prone or costly, and reflow does not work reliably. So I would say it's fair to say we are stuck. To help us understand why, it's good to understand why is structure recognition difficult. And again, here there are multiple reasons. One of them is, again, that we don't have a well-defined grammar or a set of labels that we're trying to recognize. So we don't have so-called Unicode or document grammars, like we have, let's say, in OCR field. Each logical structure recognizer is mapping to its own structure representation, and there is no way to compare different solutions or to improve the state of the art in the field. There's no well-defined taxonomy of different document structures. Also, some solutions are trying to map everything to a specific logical structure, like HTML or words, and these solutions will always fall short for various reasons, one of them being that there is a trade-off between preserving the visual accuracy of the original and fidelity of the original document, and also preserving more and recognizing deeper and more meaningful structure. Another reason is that for complication with the structure recognition is the classification task is affected by many more factors, let's say compared to typical OCR. So we have to deal with things like font size, style, typography, spatial arrangements, groupings of elements on the page. There's background, white space structures, the location of element within the semantic tree, and so forth. So actually, this listing is just a small sampling of all the factors that might be involved in the classification task. And the most tricky part is that many of these factors are influencing each other under certain circumstances. Frequently, the classification of the document grammar or the document classification might be influenced by low-level factors, like in the structure tree, and the other way around. The classification of lower-level elements may be affected by the top-level document classification. So it's a chicken and egg problem. The bottom line is that these complex and vague knowledge dependencies are near impossible to handle in a kind of conventional rule-based style of programming. And any serious document recognition system would need to rely on machine learning techniques to encode knowledge extracted from data. Interestingly, most current in the industry solutions are still using these rule-based kind of programming heuristics techniques, and they settle with fairly shallow structure representations, and as a result, they have relatively limited capabilities. On academic side, most approaches focused on, even the approaches frequently use machine learning, they usually focus on individual components of a document understanding system. So they might be recognizing headers, footers, page numbers, table of contents, tables, but they rarely address the document understanding problem as a whole. And the complexity actually lies in interaction of all of these components. It is simple, but simplistic to just focus on individual components in the system. So the big problem with the big picture is the so-called high-interest credit card of technical debt in machine learning applications. So this is actually a title published by Google Research, I think last year, which states that the technical debt in machine learning applications tends to accumulate much faster than in traditional software projects, and leads to generally bad things such as boundary erosion, data dependencies, and spaghetti code. So for more information about this article, you can just refer to the above link. Unfortunately, at PDFtron, we arrived at a similar conclusion a few years before our article was published. And the credit card analogy especially hit home because we were dealing with rapidly rising cost of development for ever decreasing increments in recognition accuracy. So we were stuck, and we decided to put temporarily this project on hold until we had a better idea how to deal with the system complexity. And apparently we were not the only one facing this problem, because the research in the current state of the art in the AI revealed renewed interest in things like multi-layer neural network, convolutional networks, probabilistic programming, and similar techniques, which are now under a new umbrella called deep learning. To be fair, these techniques are not particularly new, and we were already using some of them in our old system. What's different is that some recent breakthroughs made these techniques more practical. For example, in terms of the amount of training data required to train multi-layer networks to computational cost required to train the network. So in general, the promise of these models is that basically they can capture abstract features and patterns concealed in the data for us. So in our case, that would be semantic structure information. So the focus is now shifting from us trying to explicitly encode all the rules of document understanding, most of which we are not even aware of, to letting machines figure out the patterns in the data and then figuring out the structure. To validate whether these new deep learning models work, we looked at their application areas, and we found some impressive results. One most notable example being ImageNet. So what is ImageNet? ImageNet is the world's largest database of labeled images with more than 40 million labeled objects. So it's just a database. It's not a recognizer or algorithm or anything like that. It's a website which also runs visual recognition challenge, which is by far the most popular machine learning and computer vision competition of all time, with research with teams from all around the world, from universities and companies submitting their recognizers for the competition. So to give you an idea, we have a picture here from ImageNet database where Google Linnet recognizer, so submission from Google, correctly identified dog and a hat with a wide brim as present in the image. Now the interesting or amazing part of all of this, for me personally, is that recent submissions exceeded human ability to identify objects in photos. So a recent, just a few months ago in February, submission from Google and Microsoft achieved error rate at 4.8% on image classification task, compared to error rate for humans, which is average around 5.1%. Now we can go into arguments. Okay, human error rate is not a fixed point, but a range. And of course, image recognizers or machine recognizers are still not good in certain areas, like recognizing more abstract concepts like art. However, there is no doubt that there was amazing progress achieved in this area. And the most amazing part is how quickly it how quickly these innovations and improvements are occurring, just like during the last 5 years. So the obvious question is then, can we apply lessons from ImageNet and techniques from ImageNet to the field of document structure understanding? And can we do something similar for, like ImageNet for PDF? So again, I want to emphasize that ImageNet is not a particular learning scheme. It's not about deep learning, although most recent submissions from most competitors do use deep learning techniques. But it is just a database and a forum for a community to get together and to be able to scientifically compare different approaches and to make a progress in the field. There's a competition aspect. So the first starting point is that we are missing the ground truth, the database. But before we start even building the database, we need to do some preliminary work to decide what the database will look like, what it will contain. So we need to do some spec work. The first step would be that we need to come up with we need to agree on a common set of labels that we're going to recognize. If you're not sure what we're recognizing as a community, it's going to be hard to have a common measuring stick. As a comparison, ImageNet is organized according to the nouns in WordNet hierarchy, which is just English lexicon, where each node of the hierarchy is depicted by hundreds and thousands of images. So if we wanted to do something similar with PDF, as a starting point, we could just adopt standard PDF structure types and Matterhorn protocol to guide labeling without reinventing too much wheel. For document classification tasks, perhaps we can just look at existing library classification systems. And there are already a number of these systems currently in use. Almost every library is using their own system, but there's big ones like Library of Congress classification system, DWAY classification, and many others. So we could just adopt one classification system that makes sense for the field of document understanding. And it doesn't need to be perfect. So many researchers on ImageNet are complaining about WordNet hierarchy because it was designed many years ago, like 50 years ago, and doesn't include new concepts like iPads and Lady Gagas and so forth. But it is a good starting point. And the main thing for this proposal, the stuff we're talking about, is just a way to bring the community together and to kickstart innovation. So the last step is to figure out the format that we will use to store labels and the document structure. And the most obvious solution is just to use tagged PDF or PDF UA. However, there might be better alternate representations. So for example, at PDFtron, internally we used just standard PDF annotations to label documents. We associated a specific color with a specific annotation, which was drawn on top of the document. And we found that this significantly simplified labeling and processing tasks, which are critical when building the database. It also separates the labeling from the document, so labeling can be stored as XFDF externally from the document. So with all this spec work, we can then start building the database. ImageNet labels were created by humans with the help of Amazon Mechanical Turk. And reportedly, there were more than 30,000 people involved on the projects. So all this effort was crowdsourced, and it was funded by research grants and by industry sponsors. So we can say it was a massive undertaking. And it's unclear whether we can use the same approach in the area of document understanding and PDF.
Sorry, what is Mechanical Turk?
It's Amazon Mechanical Turk. So basically, it's a way for crowdsourcing certain tasks to a pool of people where they perform certain tasks, mechanical tasks, usually for a very small fee. So the researchers, so they were considering doing the labeling task by a dedicated researcher or labeler, operator, and they computed that it would take multiple decades to do this by their laboratory team. So they decided that this has to be a crowdsourced effort. So besides so the question is, can we use the same approach for PDF? And again, it's besides the funding issue, it's unclear whether we can scale, whether we can use the same approach here. Comparatively, ImageNet labels are both simpler and fewer in number. So a single PDF document may contain hundreds or thousands of labels, whereas a single or couple of labels for a typical photograph. Also, the labeling process is more involved, and operators need to be skillful in labeling the document. They might need to be familiar with things like Matterhorn protocol and so forth. So is there anything else we can do to move the field forward? Can we build a database without major investment? And a solution may be to set up a process rather than a database. So instead of labeling and like investing significant resources into building upfront databases of ground truth, we can simply let existing recognizers auto-label documents for us. And then the system would compare the outputs from different recognizers and channel conflicts to a human review team. So to go into more detail, here is how this could work. So we would need an organization which is hopefully not affiliated with any commercial entity. So perhaps PDF association. So the organization would set up simply a website where any interested party could register their semantic recognizer via simple REST interface. So the recognizer then would be given a task to auto-label a document, which might be, let's say, sampled from the web. The recognizer would then return the result in a standardized format, let's say XFDF, and the system would then be given a task to compare outputs across other recognizers and submit eventual conflicts, if there are any, to a human reviewer for resolution. So human would decide which recognizer is right. The site would also keep track of history of all operations and automatically rank recognizers based on their accuracy. So what are the advantages of this system? To start with, it's not a big investment. So as a community, we don't need to seek for big investments to kickstart a project. We don't need to build a ground truth. We don't need to work on definite implementations, and so forth. Importantly, most of us are already familiar with this process. So we use continuous integration techniques in most of our workflows. We use it for automated builds. We use it for automated regression testing. Most of us use it for, to compare image accuracy of rendering and so forth. So this is just the natural extensions of systems that we already use. And the net effect is that this would bring entire community on the same page. It will also serve as a catalyst for innovation. So the overall system, like if you look at the continuous integration side, as well as all the recognizers, would function via evolutionary-like process, where the ground truth would improve the recognizers, which would then, through automated ranking and competitions, improve the ground truth in a kind of a self-reinforcing loop. And this is nothing new. Again, ImageNet is just an example of a general pattern that we see repeating in communities. So there is Kaggle competitions. There's what is it? The Netflix challenge for ranking or movie recommendations. Space One challenge, and so forth. So it's a model that works. So to summarize, it seems very likely that deep learning will revolutionize the field of document recognition in coming years. And the only thing that we as a community are missing at the moment to kickstart innovation is the ground truth and a way to rank recognizers. But we don't need any major funding to get started. So the major fear, I guess, to start something like this is that there is funding, that we need to build a complex ground truth. We could instead use focus on process and use these evolutionary processes to improve database and recognizers. And the interesting thing is that we can use exactly the same process in other areas. So as a PDF association, we are dealing with PDF validators, like PDF-A validators, which are not agreeing with each other, or rendering outputs which are not in agreement. We were hearing earlier today the keynote presentation about fragmentation of PDF ecosystem, which is undermining the core value of PDF as a kind of medium for accurate document representation. So we could use the same process here and then compare just the results from PDFA validation or rendering, or just compare rendering outputs across different rasterizers and so forth. And I believe that this might be a game changer and solution to many questions raised during the session. So that's it. Thank you very much. In case you have, in case some of these ideas resonate with you, or if you would like to join a potential project, you can reach me at info@pdftron.com. And if you're interested to learn more about what we're doing at PDFtron, you can take a look at our website as well as our showcase, zodo.com application. Thank you.
It's a very cool idea. One thing that strikes me is that, compared to image recognition, where you've got a kind of canonical representation, let's say a 2D array of pixels to work with as your basis for recognition. In PDF, the equivalent would be the rendered PDF onto a screen, because there's no canonical representation of a page with a triangle here and text in this font over here. It can be represented in PDF many different ways. And if the goal here is to, let's say, add tag structure or some representation to the PDF so that it can be reflowed and so on, we need to be able to work in that domain. So do you agree that it seems to me a complicating factor here?
So the complicated factor is that the PDF is vector-based versus raster images?
No, not quite that. It's that you can take something that visually appears as a page, an image over here, and here's its caption, and here's a background color, and all these things that appear to you as those descriptions when you look at it, it could be represented in the PDF list of ops in many different ways.
Right.
So how do you apply a recognition scheme to this thing that can be represented so many different ways?
So at PDFtron, we actually spent many years solving this problem. We were working on it for like at least 10 years. And we're coming up with a new way of approaching the issue. I believe that it's possible that like all of our, so the purpose of today's discussion was to look at a way that can bring us as a community to a kind of a common format, a platform that can use as a building ground for comparing recognizers and different solutions.
Mm-hmm.
But it is not about like how we are implementing different solutions. So that's going to be still your secret sauce for every company.
Uh-huh.
And yes, we are certainly having certain techniques of abstracting these concepts.
Yeah, that almost seems like the area where you could apply machine learning.
Yes. So the interesting thing about these multi-layer networks is that essentially they look at the feature in the inputs and the layers. The layers in the network corresponds to certain abstract features. So in case of ImageNet, the first layer of recognizers would recognize edges, and then higher levels of would recognize things like eyes, and there would be even like a higher recognizers which represents a face. All that is done in automated way. So in case of PDF, we would not work, I guess, with pixels themselves. We could start from higher level representations like bounding boxes and lines. So there would be like, it would be interesting how to map this into building blocks that can be used as inputs for neural networks, how to do this mapping. Also, how do we understand this system? Like when it's doing its learning, it has all these abstract representations, but then how do we know that this node in the network represents a table or some specific label?
Right.
So the current breed of deep learning algorithms are not actually that good in this hierarchical recognition tasks.
Mm-hmm.
So this, I'm not saying that all the techniques that are currently in use for ImageNet would directly apply for for PDF structure recognition. But there are certain developments that might make this possible soon. Go ahead.
I had I guess, a technical question. Just when you mentioned using annotations instead of using tagging. First of all, I noticed you didn't mention using the metadata, that's XMP. Second of all, I was wondering, are you talking about labeling the whole document, which is one approach, or labeling aspects of the document, which is the other approach, right?
Mm-hmm.
When you tag things, you tag a specific paragraph or a specific heading or a specific table, right? And I was wondering, but when you, but then you went on to annotations, and it sort of sounded like you wanted to label documents as a whole. Were you thinking of both?
Yeah, internally, so in our systems, we were labeling document as a whole. So,
Right.
so we had our system, like because we didn't want to do all the labeling ourselves, so we had our recognizers to go label documents for us, and then we had a human operator who just examined the annotations floating on top of the documents to quickly determine whether there was a misclassification.
Right, but they weren't geographically relevant, right? In terms of the annotation didn't say, hey, this area is a paragraph. It just said this document has a paragraph.
No, actually it said that this area is a paragraph.
Okay, so it was geographically
Yes,
relevant.
so
Okay.
that's why we're using annotations. So
Okay.
we just use annotations to specify what specific region of the document represents. And that's how we are decoupling the physical representation of the document, which may be stored in an infinite number of ways
Yes.
from the visual aspect.
So this is like, I'm just curious, if I'm using an editor like that, at the time when I generate the PDF and all the structures are already there. In fact, I can actually buy corpus that give you pair PDF and LaTeX. So is it possible to use LaTeX as a single vision for the PDF? And in fact, I'm just wondering whether there's been any work try to turn PDF back into LaTeX.
I'm not very familiar with LaTeX, but so your question is like if we have some semantic labels in the documents already, can we use them as to build the ground truth?
LaTeX is, if you think about it as a structural work tool, right? I mean, this is basically the tool that is being used to write technical papers around the world.
Mm-hmm.
So there are many, for example, Archive, for example, is like a really huge website where people just go and post their papers there. But in fact, the site actually asks for LaTeX sources for them. And it does the PDF generation automatically.
Okay.
So on such a site, you actually have paired of, on one hand, PDF, which is the output of that process. On the other hand, LaTeX source, which is basically contains all the structure. Like it tells you this is a paragraph, tells you this is a table, it tells you this is a figure, and so on. Right?
So what is the question?
The question is whether can you use that as the source for supervision.
Are you suggesting that that's the ground
just
truth?
take a PDF.
Yeah, so I mean you can use that as a ground truth. Like, but there is so yeah, we need some ground truth. So we want to kind of solve the problem for general situation, like for files that don't have any semantic structure. So yeah, you can use these labels or any like existing PDA UA files or any corpus of documents which are labeled as a potential ground truth. The problem is that as a community we don't have LaTeX might be using one kind of logical representation structure, and then another application might be using something different. Like there are applications like we saw earlier today which are mapping PDF to HTML. They have some certain ideas about what they're mapping to. They might not have things like concept like table of contents, footers, header, page numbers. They're just dealing with like paragraphs and maybe tables. That's about it. So there's no agreement like as a community what is the ground truth. And the purpose of this project will just be to say, okay, this is the ground truth. This is the labels we want to recognize. Here are the test files. Let's run the competition and see and improve the state of the art of the field.
wouldn't that be an easier way of doing it then? Instead of trying to collecting random PDF files and trying to go back to what the truth is in those files, is by allowing people to submit files that are highly structured, converting them into PDF on the fly, probably in multiple ways, and using information from that. I mean, if you allow someone to upload a Word file, for example, from which structure can be derived much more easily, and that gets then turned into PDF, you have the structure information and you have the PDF file that corresponds to it, and you might actually get there a lot quicker.
So that can definitely be one source of ground truth, like especially if we can agree that this is the set of labels we want to recognize. Let's say that Microsoft Word is the model we want to. Like, it's important to know that Microsoft Word is not it's not an application that can be used to generate any PDF documents. Like, can it be used for children's books? Or can it be used for like brochures, like something that maybe Adobe Illustrator would be designed. So yeah, this is the approach that many applications are using to do like PDF to Word conversions, but it doesn't solve the general problem.
I'm not suggesting to limit yourself to one format.
Okay.
But if your input is Word files and InDesign files and LaTeX files and a whole bunch of input formats, and you're capable of capturing the structure from that, and you have the final PDF result,
Right.
you actually have both things, and it might be much faster than trying to relabel files once the information has been lost.
Yeah,
but
definitely.
you have to have well-structured documents to start with, and LaTeX is not well-structured. It can be. I can write LaTeX tags that will, but I can, if I want to produce a specific appearance, I'll abuse the heck out of LaTeX to achieve that. The same is true with Word. I can do a very, bold, and I can do.
Right, but those are the files that you wouldn't include in the set.
So you then have to choose a good source set, which is very hard to define, and because you have lots of different classifications, it's very hard to then find those canonical.
One of the inputs. So I think this part is like, so individual PDF recognizers could choose whether they want to take advantage of existing logical structure in a PDF document. So let's say your PDF document is coming from Word and has all the facts in. Your recognizers could choose to respect those. And then we would just simply compare the result of this advanced recognizer with others recognizers, or perhaps with a recognizer which is Amazon Mechanical Turk, and we can come up with any conflicts. I mean, we cannot rely on those logical stacks as being fully correct.
I don't think that the proposal I hear is to say that use LaTeX or use Word as your ground truth. I mean, the other person is saying that it's much easier to convert from Word or LaTeX to your agree upon ground truth rather than from PDF. Yeah. So it's going to say problem with the annotation.
I think the problem with that kind of approach, where you're taking a known set of documents from, even if it's just from some source like LaTeX, is that you might overtrain your recognizers into some domain, because it's probably known that LaTeX is the basis for scientific papers mostly, or you might say most scientific papers originate in LaTeX. So you do have a great recognizer for scientific papers, but it wouldn't be generalized.
But you could parse it by source. You could say, where are these documents from? And if it's from LaTeX, and you go, I'm going to apply the ground truth to LaTeX, right?
Mm-hmm.
So-
Yeah, you
so
can have
that's not-
segmented
because
outputs.
different
Yeah, but it will always be easier if you start work with the source file. It will always be easier to retrieve, I don't know, a desired result from that, or a ground truth from that. And you may, I don't know, what you could do is, of course, you can create a PDF that is perfectly tagged, if possible, from the source file, and then just remove all the tagging stuff and then put it into the recognizers.
Yeah, I mean, we can use this as a kind of, the thing is that, so what I'm suggesting is that we could just let recognizers do their thing, label the thing, and then we can compare them and see, like with annotations, actually this comparison is very nice, because we can do just like rectangle or region intersect between different solutions, and then find out the differences. And then we can have a human reviewer just examine those differences quickly, And if there's errors in the original source structure, like of tags, then that would be detected quickly. And maybe then the recognizers would decrease its trust into internal semantic structures and stuff like that.
I just want to point out that we're 10 minutes past the limit for
Okay.
this session, so I'm going to feel free to leave and other people.
Yeah, definitely. Feel free to leave. Thank you very much.